Next up, I would like to introduce the head of global at API7.ai, Zhiyuan Ju. Can you hear me?
Hello, can you hear me?
Yes, we can hear you and we can see you. Perfect. Thank you. You are going to talk a little bit about why API gateways are essential to business. So
yes,
without further ado, I'll hand it over to you, and you may start. Thank you.
Okay. Hello, everyone. I'm Zhiyuan Ju from China. Today, my topic is about API gateway is essential to business. First, about me. I'm Apache Software Foundation member since this year, and I'm happy to speak here. About our company, I will introduce it later. And let's go. The first one is about APIs. You can see in the left panel there have many APIs, apps, mirror services, and IoT devices. They will use different the here is or others. In evolution, I will introduce monolithic and
Seems we are currently experiencing some lag on your end. Could you perhaps check the connection, and then we'll check in with you. Okay, sorry about that, everybody. He mentioned earlier that he had some connection issues, so we'll wait a little bit. And in the meantime, I would kindly remind everyone to have a look at the partner village. Our kind sponsors have put up a treasure hunt where you have a chance to win 4,000 Hong Kong dollars. So while we wait a little bit, let's all have a look at that. And yeah. I suppose in the meantime, we can recap a little bit about what we've gone through today. Oh, there we go.
Yeah. Sorry.
No worries.
Monolithic. The monolithic architecture is considered to be a traditional way of building applications. You can see in the red panel, this unit contains all necessary components like database, Node.js app. A monolithic application is built as a single and indivisible unit. Usually, such a solution comprises a client-side user interface, a server-side application, and a database. Just like I described just now, it's unified and all functions are managed and served in one place. But it has some disadvantages, like large code base and lack modularity. But its advantage is we can only maintain one unit. Yeah. The next evolution is about mirror service. Mirror service architecture style is an approach to developing a single application as a suite of small services, each running in its own process and communicating. Often an HTTP resource API, you can see in the right panel, the single one unit is split into multiple parts. And we only need to maintain each of them. But the challenge is, you can say we have many amounts of APIs and API security, how to make our API protected. and quick debug. How do you know which service is broken? The third is about service mesh. About the service mesh, it's usually used for service-to-service communication. It's responsible for the reliable delivery of requests through the complex topology of services that comprises a modern cloud-native application. In practice, the service mesh is typically implemented as an array of lightweight proxies. We usually call it sidecars. We only need to proxy traffic by the sidecar from the history component to the new client. So about next topic is about API management. In today's meeting, I will mainly introduce API gateway, but we can also know about the design, develop, test, publish, monitor, and retirement, the full lifecycle API management. About the design, usually we need to define what's the URI, what's the methods, and we need to develop it and test it before publish. After publish, we need to monitor their behavior. So about API gateway, why do we need an API gateway? Because the first beneficial is we can implement non-business related logic on the API gateway, like authentication, authorization, and rate limiting. We don't have to create those logics one by one. We only need to implement them once in the gateway. The next one is about reduce its number of requests or round trips. For example, the API gateway enables clients to retrieve data from multiple services with a single round trip. And third benefit is simplifies client by moving logic for calling multiple services from the client to the gateway. The last one is about translates from a standard public web-friendly API protocol to whatever protocols are used internally. Of course, there have more benefits, but we can learn them on the internet. The next one is about security. Usually, when a company introduces API gateway to their business, the first thing we need to consider is security, and then its performance. About API security, it means the practice of preventing or mitigating attacks on APIs. APIs work as a backend framework for mobile and web applications. Therefore, it's critical to protect the sensitive data they transfer. You can see usually there have some kinds of attacks like broken user authentication and code injection and circle injection. Also, security misconfiguration like we will publish the secret key to Git publicly, and insufficient logging and monitoring, and more. About the performance, like because we will use API gateway to proxy all traffic of our business. So the first component the client traffic hits is API gateway. If its performance is bad or not good, then the API gateway will become bottom stack. So we need a high performance API gateway to connect any APIs efficiently and securely. The next one is about open source. You can see in the right panel, this screenshot is from CNCF. You can see there have many kinds of open source API gateways like API 6, Kong, MuleSoft. Why do we need an open source API gateway? Because API gateway is an infrastructure component. When we use it, we seldom change it because it costs much. And open source means there will have many global contributors, developers, building software together. And it's well tested because in open source community, there has no QA team. So we have to use many test cases to make sure the product is good as possible. I like to introduce Apache API 6. You can see it's an Apache software. And so what's API 6? It's an Apache Software Foundation top-level project and donated by API7.ai Inc. in 3 years ago. And it's dynamic, real-time, high-performance API gateway. I will introduce the 3 concepts later. And it provides rich traffic management like dynamic upstream, authentication, observability, and more. Not only API gateway, it also provides ingress controller and service mesh components. In the red panel, it's API 6 architecture. As you can see, it has 2 parts, the data plane and the control plane. In data plane, API 6 has many plugins like rate limiting, security related, authentication related, and client requests hit API gateway, and API gateway proxy those requests to target upstreams. In the control plane, you can see we can use a RESTful API to write data, write the configuration into etcd, and etcd will watch keys change and sync back to API 6. Also, API 6 is stateless. It means we can scale it as many as possible, just as our needs. I'm not sure if everyone heard about Apache Software Foundation. It's a foundation actually in our world. We have many big companies are using Apache softwares like Kafka, API 6, and HTTPD, the web server. The Apache Software Foundation incorporated in 1999 with the mission of providing software for the common good. Today, the ASF, the Software Foundation, is the world's largest open source foundation. And it has many code base, and it's non-profit. So many people ask me, why build a new API gateway? Because there has many other products like Kong and AWS. The reason why we built new API gateway is because we noticed there have some disadvantages from other products, like Nginx serves many traffic in our world, but it doesn't support hot reloading the Nginx conf changes. It means when we have many conf files, like 1,000, it will usually take some minutes to reload the changes. And for Kong, because Kong is using PostgreSQL as its data center, and the PostgreSQL becomes a bottleneck sometimes. Also, the route matching efficiency decreases when having many routes, like thousands or many and more. The next reason is because we want to use API 6 to unify API infrastructure, API gateway, ingress controller, and service mesh. In the first screenshot, you can see from monolith to service to middle service to Spring Cloud or Kubernetes or service mesh. There have many products here like Apache, Nginx, Proxy, Kong, Ingress Nginx, Traffic, and Mawson. But it will increase the difficulty in a company to maintain all those infrastructure. We hope to use API 6 as a core to provide gateway, controller, and source mesh solution. In the next screenshot, you can see we can use API 6 as an load balancer and use API 6 as an API gateway and use it as ingress controller and source mesh. But the core is API 6 itself. Ingress controller and source mesh only provides a converter to translate some contents into API 6 formats. Also, if you are using Java like Spring Cloud, we can use API 6 Java plugin runner to use Java maintain API 6 plugins. So about dynamic, what's dynamic? It means in API 6, the root, upstream, service, consumer, SL are hot reloaded. It means we don't need to use Nginx reload to load the configuration. Just use a RESTful API to make it take effect. Also, the plugin is hot updates. We can use RESTful API to reload all plugins. No need to restart API 6. And it supports dynamic load balancer and health check and more. Why do we need dynamic? Because when we reload the changes, the connection will hit failed, especially in WebSocket. But using API 6, it's relying on Nginx, the network module, and OpenREST to make it work. And just see this architecture. Why it's real time? Because Nginx takes very long time to reload, and Kong usually takes 5 seconds to fetch configurations to protect PostgreSQL. And we use etcd as API 6 data center to make it work less than 1 millisecond. When users use dashboard or RESTful API to create a route or delete a route, it will take effect immediately and sync to all API 6 instances. Next one is about its performance. You can see there has one API 7. Actually, API 7 is a commercial product based on API 6. The gateway, the data plane is the same. And we did this performance benchmark testing last year. You can see here are 2 cases. The first one is in single node, and if we have more routes, API 7 like API 6, the performance is higher than Kong. That's because API 6, the route matching algorithm is okay, and Kong is ON. N means the total number of routes. The more routes we have, the more resources it spent. Another reason is about the IP matching algorithm. API 6, the algorithm is O1. The third reason is API 6, every plugin is carefully optimized. API 6, all of API 6 plugin, nearly 100 are open sourced and have been verified in very large traffic in many companies like Tencent and WPS. And the next reason is because API 6 data plane is stateless and no single point of failure issue, and it's highly scalable. When traffic arrives when a large traffic hits, we can just scale API 6 instance freely. About the security, this is the most point our users careful. API 6 internal plugins to connect OpenID provider and using authentication plugins to do some like JWT and kickout and basic counts, those normal authentication methods. Also, we can use rate limiting plugins to limit traffic. You can find all those plugins in API 6 the GitHub repo. The next one is about its plugins. You can see in the beginning we choose Lua to write plugins. That's because Lua supports changes in runtime. And for now, we support plugin runner. We support to use Java, Golang, Python, even Node.js to write plugins. And they communicate with API 6 core via RPC. And recently, we support Wasm. It means we can use Golang, Rust, JS to compile them to Wasm bytecode and run it in API 6 core. Thanks to community developers, where they live? Usually they live in GitHub, Slack, mailing list, and our meetup. Just visit this link to join our Slack channel to meet those friends. In the past 3 years, the API 6 repo hits nearly 10K stars and nearly 500 contributors from all over the world. And we will discuss many things in mailing list and Slack channels. Next is about our contributors. We have 27 PMC members to maintain the project, maintain the community, to answer questions in any channels. Also, we have only 19 committers who have permission, write permission to the code base, and we have nearly 500 contributors. You can see in the red panel, there have 4 open source API related products, and API 6 grows very quickly and fast. Next is about our community meetings. Since this year, we will regularly host global community meeting online, and we will have many volunteers and PMC members to join in to discuss things. The next one is about community support. In our GitHub Slack channel, we will usually have many questions here, and because we communicate asynchronously, so when needed, we will choose to book an online meeting and just give the user an calendar link, and they can pick a slot, and we will meet each other online to help them resolve questions quickly. Here are our global users like Airwallex, Amber, NASA, and Tencent. You can visit api6.apache.org to read our use cases. The last part is about API 7 Cloud. Here is a quick introduction. API 7.ai Inc. provides the cloud product to the world, and we can use it to manage all APIs in any cloud providers, and deploying, controlling, visualizing, and monitoring just in one place. Visit this link to sign up. Thank you. Simon.
Thank you very much for your sharing. That was a very interesting talk.
Hello.
And I just want to ask a few questions, making sure that you can hear me right now. All right.
Yeah.
So as developer Steve mentioned, he said Lua, and I also want to ask, why did you choose Lua for creating plugins?
Yeah, in the beginning, the first reason is because we built API 6 based on OpenResty. And OpenResty supports using Lua to write plugins to run to execute some phases in the runtime. That's why we choose Lua to build plugins. Also, actually, we only use engines to export one location. All requests hit one location, and the location use Lua block to proxy traffic to the Lua codes. Yeah.
I see. And if I understand correctly, you actually also support Golang. Is that correct? Yeah. And what was the decision behind that?
That's because our community users feedback that they are using Golang to maintain some API products, and if they want to change the infrastructure first, so we release the feature to allow them to use Golang to write codes and convert it to API 6.
Okay, thank you. I have one final question. I want to ask you, as a contributor, what was the biggest challenge for you when creating API 6 as we know it right now?
Sorry, as a contributor to contribute to API 6 or?
Yeah.
The biggest challenge is to learn Lua first and learn about some basic concepts inside the API 6. But it's easy to understand as we have documented those concepts in our documentation. Yeah.
And if anyone is interested to contributing to this project, how would they do that?
Just visit api6.apache.org, and here has one direct link to join our each channel. Yeah.
Okay. Thank you again very much for your time and for your presentation. It's really an exciting project, and I hope you have a good rest of your day.
You too. Thank you, Simon.